So I want to just take a look at what I've found you pretty much have to do when you're setting up a process on your computer to deal with basically sending G-code to a printer or some sort of like Marlin-based CNC. And the real key comes down to following your acknowledgements or handling them. Yeah, so what's going to happen is you're going to start off by creating some process that sends periodically. You might be able to do something clever with like multi-threading or something, but usually I would set this up as some sort of like timer-based function where every millisecond it's just trying to send out a next command that you put in the buffer, and so that buffer acts as like a first in, first out, where whenever you need to do something, you put it to the buffer and let the buffer handle when it actually sends. So we've got that set up, and we can fill it with G-code, right? It could be whatever size list you want of just G-code commands. And another thing we want to set up is this flag, and I usually call it like ready or machine ready or something like that. It's a global flag that anything can just kind of look at. I know some people say you shouldn't use global flags, but I do because I'm a firmware guy. Anyways, so we've got that set up. Now, some stuff just got added here. With our send process, right, every millisecond we're going to try and send a new command. But we have to have a check. We have to say, is the machine ready? If it's not, right, so is the machine ready? If it's not, then we do nothing, meaning that for that millisecond, we didn't do anything. Essentially saying that we're waiting, except for we're not waiting. We just let the process stop taking control of the processor and let something else happen. So we just do nothing. If it is ready, right, the machine, if we do know that the machine is ready, meaning that the flag is true, and what sets this flag to true, well, I'll get to that. But if it is ready, that means we can send a command. And so we send this command over to Marlin's buffer, and we also set our flag to false, meaning the machine is not ready. The reason that the machine, we can assume, is not ready is because we haven't received an acknowledgement from it yet, and we haven't parsed that. And so that's what we need to handle now, is we set up some sort of other parallel process that is receiving. And so every millisecond, it checks to see if it's receiving data. And so it can receive some other types of stuff like positional information or end stops being hit or things like that. But the big thing that we're concerned for in this context is it quote unquote okay? That's literally what the message would be, is okay for acknowledgement. Is it okay? If it is, that means we can set our flag ready back to true, right? We can set it back to true, and then the next millisecond will tick, and the send process will say, hey, is the flag ready? Is the machine ready? Is ready true? And in that case it would be, and we'd set it and set it back to false, and we'd wait for that okay. Right, and so this is kind of what the entire system looks like, right? So Marlin's buffer only, these commands are only executed when they can be executed. And so you would think, well, yeah, but why do we even need a buffer? Why didn't you just handle a command the moment you get it? Well, the thing is, this movement here, this G1X5Y10, that takes time to move, if we're starting at 0, 0, to move 5 units up and 10 units over, sorry, vice versa. But, and so when that's executing, that's when Marlin is allowing its buffer to fill up with the next commands. And then once it does fill up, so we're saying that we've got a buffer of 6 commands, when it does fill up, that would mean that it's not sending a acknowledge because it's still executing some action and there's no room left in the buffer. And then the moment this command completes, right, the firmware is going to say, is the action done? The moment the action is done, it's going to start executing another function and also send a message, okay, saying that, okay, I can receive another command into my buffer. And so then what happens, the receive process gets it and says, oh, I just received an OK. I'm going to set the flag ready to true. And then the send process, the next millisecond tick will say, oh, look, the machine's ready. I can send another command. So what that results in is right when your print starts up, sorry, not necessarily print, but when your process starts up, you'll be able to send a bunch of your commands really fast until the buffer fills up, and then you're going to have to wait for that physical time that it takes for that physical action to execute before you can send another command. Yeah, and so there's some instances like long movements where you'll have lots of time. There's other times where you have like small curves that it's a bunch of little tiny movements in quick succession, and sometimes those will happen faster than you can send commands, and or just as fast, and your buffer will actually deplete, and you'll have some extra space there. So this system is pretty flexible. That you're not counting like, oh, it should take this long to execute this command or anything on your process side. You're basically using the acknowledges the way that they're supposed to be used. So yes, you pretty much must follow this system in some way, shape, or form. The big thing is that you acknowledge your acknowledgements, right? You actually use them the way you're intended to, and by doing that, you're respecting Marlin's buffer. And then, of course, on your own end, you have to respect your own buffers. But if you ignore the acknowledgements, and for little things like a little test to send like a single G-code command, you can totally ignore them. But when you're trying to send multiple lines, it's critical that you pay attention to these processes. Yeah, and I suppose it's worth noting why this process and this process are being done in parallel. And if you don't know much about making like programs for a computer, right? If you're used to like a single core processor, right? You're used to pretty much just one thing at a time, da 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 da. And usually your process on a computer is still going to be assigned to one thread, and so that means that you're still kind of doing one thing at a time. And what that means is, if you keep to that mindset, you can't really send and receive specifically at the same time. I mean, there is some hardware things that happen. Anyways, setting up these individual timers kind of allow you to not get bound up just waiting for something to send or waiting for something to receive, but instead just say every millisecond, I want to try and see if I can, and if I can't, then I'm going to do nothing, essentially. So that's why I usually go that way. These are all kind of things that you need to implement if you're making a kind of a custom software to deal with 3D printer related stuff.